Okay, hello everyone. So we were going to have a new topic today, and this will be about we will learn how to calculate the sides of a right triangle using a Pythagorean theorem and why it is helpful. So we have the three success criteria. First, you can determine the measurement of the sides of a right triangle. Then you will going to use or calculate the sides using a Pythagorean theorem. Then you need to prove that right triangle exists using this theorem. All right. So we are using Amplify Classroom to learn this topic, and we'll try to explore what can we do or why this website is helpful in learning this specific math topic. Okay, so we have our starter. So we're going to roll the dice to get a sum of seven. And how many the rolls will it take for us to get a sum of seven? Let's see. So we're going to highlight these dice. Then first roll, it's not seven. Second roll, oh, that's nine. Third roll, oh, we get seven. So we get three rolls. Okay, four before we get seven. Then we can share it with class, or you can edit your response later on. That's good. And we have next part. So we have vocabularies here. So in this lesson, you will speak using these terms. Perimeter, right triangle, flags or the sides of a right triangle, the hypotenuse, so it's the longest side of a right triangle, which is located the opposite of 90-degree angle. Then square root, a value that when multiplied by itself gives the original number. Mhm. And the Pythagorean theorem. So later on, we're going to see maybe how we're going to use it. What do we have here? So the ultimate hypotenuse challenge. So the goal is to roll two dice to determine the legs of your right triangle. Draw the legs, then use a ruler to connect them and measure the hypotenuse. Okay. So the challenge, use your lack of roll and precise measurement skills to construct the triangle with the greatest perimeter in the class. Oh, so let's try to uh, check our luck. Let's try to roll the dice. So we have three and four, which is seven. So we have the ruler here. So we're going to measure three. And as you have noticed, each square unit here measures 1 centimeter each. So one square unit is 1 centimeter each. So this is our three. Then we move our triangle. We move our ruler to measure this one, just four. Then we try to measure it, draw the legs, then connect the ruler or use a ruler to connect them. So this is the hypotenuse. So we know that this is three, the other one is four, but the hypotenuse measures five. Okay, so let's try to remove that for now and click the pen or drawing tool here, and we will use the marker to label everything. So this is three, this is four, and this is five. So what do you think is the perimeter of this one? So we're just going to add everything, 3 plus 4 plus 5, and that gives us 12. So we have a 12 cm perimeter. Now let's try another one. Maybe we could get higher than 12. Let's see. So let's try to roll this dice again. Oh, we get 5, 5. So we have the ruler here. So we have one, two, three, four, five. Then for the next side, we have another 5, 2, 3, 4, 5. Now, if we're going to connect this one, let's try to check what's the measurement of that one. Okay, so it's around approximately 7, but it's beyond 7. So we can round it up our answers. So we have 5, then 5, then the other one is 7. So what do we have here? For us to get a perimeter, P equals 5 plus 5 plus 7, which is 10 plus 7, it's 17 cm. Oh, we get a higher. So I think 17 or 5 is much higher perimeter compared to 3 4. But do you think there are still, let's say, other numbers that will be higher than 17? So you can share your answer on the comment section. Then, what do we have in the next slide? So here are the possible legs of a right triangle. Oh, so if we're going to keep rolling the dice, we can see the different combinations. We could have 1, 1, 1, 2, 1, 3, and so on and so forth. So we just answered earlier 3 and 4. Let's try to look for the 3 and 4 here. Let's try to zoom a little bit. 3, 4. So we know that the hypotenuse here is 5 and the perimeter is 12. And we also know the 5, 5, which is 7, and the perimeter is 17. But what if we don't have a ruler? Okay, or what if we want to really calculate the very specific or the precise number of the sides of our triangle? Or let's say the sides of your triangle is longer than 6, or it could be 3 digit or 4 digits. So this is where the Pythagorean theorem comes in, where a squared plus b squared equals c squared. So we're going to calculate the hypotenuse using this formula for us to get the perimeter. So for example, we have 3 and 4. Let's see if we could get 5 or 7 later on. So our A is 3, 3 squared plus 4 squared equals to c squared. We don't know the hypotenuse yet, let's say. 3 times 3 is 9 plus 4 squared, that's 4 times 4, that will be 16 equals c squared. Now, what is 9 plus 16? That's 25 equals c squared. And we know that 25 equals c squared is just the same as c squared equals 25, because that's what I used to solve for the variable. The variable is always on the left. Then, for us to get rid of this exponent of 2, we square root both sides. So we cancel, and c is equals to square root of 25 is 5, which is the same thing. So I didn't use a ruler, I just used the Pythagorean theorem, and still I get the same answer. Okay, how about for the 5 and 5? I'll just erase this one, and let's try another one. A squared plus b squared equals c squared. So we know that a is 5 squared plus 5 squared equals c squared. And we know that 5 times 5, or 5 squared, is 25, plus 5 times 5 is 25, equals c squared. 25 plus 25, we get 50, equals to c squared. Then we just change their position. Then to get rid of the exponent of 2, we square both sides. So we get c equals square root of 50, and that will give us around 7.0.07, which is very close to 7, but this one is much precise compared to the ruler method. But still, it will give us the same perimeter, 17, but you can choose to use a ruler or a Pythagorean theorem, but I think Pythagorean theorem will give you much precise answers. So you can try to answer all the blanks here, the 1-1 combination, 1-2 combination, or the other combinations that you would like. Just reflect it in your notebook or leave a comment below. Then for the next slide, we have a checkpoint here. So we have a follow-up question. When is it better to use a ruler or when is it better to use a formula? So I think a ruler is much better if you have the physical triangle already where you just need to measure all the sides of it. But if you have the sides only and you still need to construct the triangles, then you can use a Pythagorean theorem, or maybe we can write here for precise answer. We can use the Pythagorean theorem. Okay, and maybe the ruler is just for approximate. So I can share it with class and I can go to the next page. Then we have the missing sides of a right triangle. So how are we going to calculate this one? So let's try a squared plus b squared equals c squared, where the a is already given. So we have 2 squared plus b squared. We don't know it yet. That's what we're looking for. And c squared is square root of 53, or we square it. Always remember this formula. 2 squared, that's 4, plus b squared equals square root of 53 squared. It will cancel the square root, and it will give us 53. So we cancel 4 both sides. Then we have b squared equals 49. So we square it both sides. That's b equals 7. And we get the value of our b, which is 7. Now you can try the 8 and the square root of 80. Let's see if we can get the correct answer. How about if the a is missing and the b is given and the c is given? So we can use the formula again. And our a is missing, so we can just copy that one since that's what we're looking for, plus b squared, which is 12, 12 squared equals c squared, which is 13 already. Then we know that a squared is still missing, and 12 squared, that's 12 times 12, it's 144. Equals to 13 squared, that's 13 times 13, is 169. Since we need to leave the a squared alone, we need to remove the 144 on this side. So we have a squared equals 169 subtracted by 144, it will give us 25. And to get the value of it, we square both sides to remove the exponent. So A equals 5. And the answer here is 5. Now you can try the other missing answers here or the missing sides. Just reflect your answer on your notebook or in a piece of paper so that you can take a photo of it or you can share your answer to the comment section. And what's on the next page? So based on what we know, how did we apply the theorem to find the missing line? So one thing we know is, as you have noticed, if the C is missing, we are adding the A and B, then we get the square root of it. And as you have noticed, if the B or A is missing, we are subtracting the either A or B to the hypotenuse or the side C. And that's how we get the answer. So maybe that could be a wrap up of this lesson. But for the last or ninth slide, we have another activity here. So we'll construct a right triangle with a perimeter between 21 cm and 30 cm. Use the ratio or use the Pythagorean theorem and label illustration to prove that your construction is a valid right triangle. So we can use Pythagorean theorem as well to prove that the two sides or the three sides can form a right triangle by following the formula a squared plus b squared equals c squared. And how are we going to do that? So we can choose any numbers as long as the perimeter of it is 21 cm to 30 cm. So maybe I will choose, let's say, numbers 6 and 7. So what do you think will be the hypotenuse and the perimeter? Okay, I'll leave that to you and always make sure to take a screenshot of your answers and save it so that when your teacher asks for it, you have an evidence of learning. Okay, so you can revisit the learning objectives. I can determine, yes. I can calculate, yes. And I can prove, yes. And that's it for today.